turn that down, and I can probably turn this off. Oh no! For the last time. Say goodbye to Anne. Well, she's taking Physics 12, so those of you that are taking Physics 12, you'll see her. Number 1, we skipped this year. Number 2, we skipped this year. So number 3, a child on a water slide passes point A at 8.3 meters per second. How fast is the child traveling at the bottom if we ignore friction? So I put a little letter I right here, a little letter F right here, and I said to myself, is there a change in height? Is there a change in speed? Is there a yucky curvy path? Conservation of energy. Gee, you know you can always put your new glasses back on. I'm just saying. Which of these are 0? I said, well, that's 0. I'll call the ground level right there. I don't think anything else is 0. It's not starting at a height of 0. It's not starting at rest, and it's not at rest there. In real life, by the way, on a water slide, you do lose a lot of energy to pushing the water, because otherwise, if you didn't, you'd be at the bottom of the water slide traveling just as fast as if you'd been in free fall on the way down to the ground, and you're not. This is going to be a half little m v initial squared plus mg h initial. You could also have done mg h initial plus a half mv squared, as long as they're both initial. That equals a half little m v final squared. And it looks like what I want to get by itself is the v final. In this case, Mesa, the m's do cancel. There is an m in everything. If you're not sure, don't cancel them and you'll be okay. And then I'm going to be a bit sneaky. I'm going to times by 2, times by 2, times by 2. You don't have to, and I'll show you what it would look like if you didn't. But if I do that, those 2's and halves cancel each other, and I end up with this. Vf squared equals Vi squared plus 2g h initial, which really is Vf squared equals Vi squared plus 2ad in disguise. And then how to get rid of a squared? Square root. And I'll get a final answer of, what was V initial? 8.3. Don't forget the squared. Plus 2 times 21, no, times g, Mr. Duick. 9.8 times 21. Square root of 8.3 plus 2 times 9.8 times 21, close off the square root. I forgot the squared, Mr. Duick. After I said don't forget the squared, I forgot the squared. Well, that would be silly. And I get 21.9, is that right? It's a pretty fast water slide. If you got that, I would give you 4 out of 4. Otherwise, 1 mark for each of these lines. But I did say I would show you, if you didn't do the multiply by 2 trick, you would divide everything by 0.5. You would have Vf squared equals 2 Vi squared plus, Vf squared equals 0.5 Vi squared plus 2 GH initial, and you would divide by 0.5, and then you would square root. That'll get you there too. It's the same thing. Suppose the child is only traveling 16 meters per second at the bottom. How much energy was transformed into heat? Ooh, Hannah, that's a good question. Now it's going to be kinetic initial plus potential initial equals kinetic final plus potential final plus heat. I can still say potential final is 0. I want to get the heat by itself. I think I will minus the kinetic energy over. I'll get this. Kinetic energy initial plus potential energy initial minus kinetic energy final. That equals heat. Initial plus initial minus KE final. So that's going to become heat equals 0.5 m V initial squared plus m G H initial minus 0.5 m V final squared. Mesa, there's an m in this term, there's an m in this term, there's an m in this term. No m there. The m's don't cancel for what it's worth. Also, because I'm not trying to get the v by itself, I'm not going to times everything by 2. It wouldn't help me at all. It wouldn't be a time saver. I'm just going to plug and chug. Heat is going to be 0.5 times, what was the mass of the kid? 45 times 8.3 squared plus 45 times 9.8 times, what was H initial, 21, minus 0.5 times 45 times 16 squared. And I get squared plus 45 times 9.8 times 21, take away 0.5 times 45 times 21 squared. Look for typos. I think that looks good. Do you get 800? Is that right? No. There's no squared on the heat. I don't need to square root it. 16, not 21. Oh, 16. On my calculator, I made a typo. That's what you're saying. I put a 21 there instead of a 16. That'll make a big difference. You get 5,050? 5,051 joules. I would give you 1 mark for that, 1 mark for that, 1 mark for that, half mark for the numbers, half mark for the answer. Yeah, no need to square root because I'm not getting a squared by itself. Okay? So probably a typo, but we'll look at it. And can you get the headphone out of your ear and the mask up? Thank you. So there's going to be a question similar to a water slide probably on your test. That's a good example. Or a roller coaster, or both. So they want the speed at the bottom of the first hill. I'm going to say initial is right there. Final is right there. KE initial plus PE initial equals KE final plus PE final. This one's a little easier because my final potential energy is 0. I'm on the ground. And it does say that I started at rest. So I'm going to get this, Victor. MGH initial equals a half little m v, not initial, final squared. Do the m's cancel? Yeah, they do in this case. And I want to get the v by itself. I'm going to go times by 2 times by 2. Or I could just times the 2 over, divide by 1, and then square root. Quinn, I'm going to get this. VF equals 2 GH initial square root. Or you could have GH initial over 0.5. Same equation. So it's going to be the square root of 2 times 9.8 times 90. The square root of 2 times 9.8 times 90. And I get 42. If you got that, I would give you 2 out of 2. Otherwise, I would give you half mark for that, half mark for that, half mark for that, and then a half mark for the answer. The next hill is 50 meters high. How fast will the coaster be traveling at the top of the next hill? There's 2 ways to do this. One way is to let the ground be right there. Can. The other way is to let the ground be the ground. Who used the first method? Who let the ground be? Okay, since most of you did, I'll do it that way. If you didn't, I'll show you later on how to do it the other way. If I put the ground right there, it's still conservation of energy. G. And because I let the ground be the top of the hill, I can say that's a height of 0, and we're still starting out at rest. We're still going to get mgh initial equals a half mv final squared. The m's still cancel. In fact, we get the same equation, vf equals the square root of 2gh initial. It's going to be 2 times 9.8. Well, if I put the ground at the top of the 50-meter high hill, and I'm starting 90 meters high, I guess my change in height is 40. Square root of that, 28 meters per second. So if you got that, I would give you 3 out of 3, probably 1 mark for that, 1 mark for that, half mark for that, and a half mark for the answer. If you didn't let that be 0, then you would get this. mgh initial equals a half mv final squared plus mgh final. M still cancel. Yay! Well, if I want to get the v by itself, I think first I would minus the g. I put an initial there. Should be a final. I would minus the gh final over. So the gh initial would drop down like a domino. Minus gh final. And then I would divide by 0.5. Or multiply everything in brackets by 2. Square root. That also equals v final. I would argue that looks a little prettier. But that should work. You would go like this then. The square root of, well, I would do the inside the brackets first. Bracket 9.8 times 90 minus 9.8 times 50 divided by 0.5. Square root of that. Yep, there we go. 28. Example 5, a full draw is the maximum distance that an archer can pull back a bow. Using the recurve bow shown below, an archer requires an average force of 130 newtons for a full draw of 70, nice try, Duick, 0.70 meters. I had somebody earlier today say, hey, Mr. Duick, are we supposed to use 100 meters or 70 meters? If you look close, the original string starts out 30 centimeters away. It gets pulled 100 centimeters away, which means it gets pulled through a distance of 70 meters. That's why it's 70 there. How much work? Here, work is going to be force times distance. It's going to be 130 times 0.7. 130 times 0.7, and I get 91 joules of work. How many joules of work? 91, right? How many joules of work? 91. How many joules of stored energy? 91. And again, the big mistake I see kids go, well, isn't potential energy mgh? That's when you're lifting something. I don't think we're lifting it. I think we're storing energy by force times distance. C says if the arrow has a mass of 18.6 grams, nice try, Duick, 0.0186 kilograms, divide by 1,000. What's the maximum speed that the arrow could leave the bow? I could do this with conservation of energy. Paige, I'm just going to say I think all of the stored potential is going to get turned into the kinetic energy of motion. 91 equals a half m v final squared. V final is going to be 2 times 91, or 91 divided by 0.5, and then divided by the mass, 0.0186 square root. That's way too fast. Oh, square root. Do you get 98.9? Fast, but not crazy bullet fast. about the length of a football field in a second. I've seen some compound bows that can fire an arrow way about that fast. Bonus. If the arrow only leaves with a speed of 54, how much energy was lost to heat? Okay. Now let's go full conservation of energy. I think my final potential energy is 0 because it all got used up when I let go of the string. It all got transferred to the arrow. The bow no longer has stored energy. I think my initial kinetic was 0 from rest. So I guess the heat is going to be the initial potential, which was 91, minus 0.5 mv final squared. It's going to be 91 minus 0.5 times 0.0186 times 54 squared. And I get 63.9, is that right? Joules of heat. So this quiz, now that we've modified it a little bit, is no longer out of 20 whatever, it's out of 17. You can get 18 out of 17, but unfortunately the software doesn't let me type that in, so you'll actually get typed in 17 out of 17, but you have the pride of knowing that you got the bonus if you needed it. Any lawyering with me? Now is the time.